Hey guys, today we're going to be looking at what's called a limiting reaction. And here's the question to start. What prevents a reaction from continuing on forever? The answer is something's going to run out. Something runs out. Imagine you have two substances, substance 1, substance 2. Okay? A reaction is going to end when one of those runs out. So the goal of this lesson is to find out which of the two is going to be the limiting or the limiting reactants. So I have an example here, and it's a ham sandwich. So we're going to make some artificial symbols for this reaction of creating a ham sandwich. So for bread, we're going to say that this is going to be the symbol BD. For a ham, we're going to say this is the symbol HA. So you'll see down here, I have 8 pieces of bread, and I have 3 slices of ham. So the question is, how many ham sandwiches can I create? I can't create an unlimited amount of sandwiches. It's going to be limited by either the amount of bread or the amount of ham. So usually you have 1 slice of ham and 2 slices of bread. So you can see my sandwich over here, which is composed up of 2 pieces of bread and 1 piece of ham. So what is the maximum number of sandwiches that I can come up with? Well, the answer to this is 3. Well, what's preventing me from making more sandwiches? And the answer is the ham. So we would say that the ham is the limiting or limited. We'd say that the bread is going to be excess. So it's what's limiting that's going to determine the amount of product. The thing that's limited, this is what determines the amount of product. Determines the amount of product. So I would create 3 ham sandwiches. I would have 2 excess pieces of bread at the end. And I don't have any more ham to make any more sandwiches, so I have excess ham, and this limits the number of ham sandwiches to 3. So let's apply this to chemistry. This is using the previous principles of grams to moles to moles to grams. So we want to determine the limiting reactant comparing moles. So we want to take a look at the sodium and the chlorine in this reaction. We're going to combine sodium and chlorine gas to create sodium chloride salt. And we're going to do this in this first reaction comparing moles. So determining the limiting reactant comparing moles. So we're looking at moles versus moles. There's 2 ways of doing this. This is involving using, again, just like with grams, moles, moles to grams, this is using the molar ratio or their coefficients. So here are the 2 methods, and you can use either of them. So assume that I start with the 6.7 moles of sodium. So we have 6.7 moles of sodium, and we have 3.2 moles of chlorine. Which one's limiting? Well, it looks like this is limiting because this is the lesser amount, but we don't know that. We just can't tell by these numbers, so we have to compare them. So let's start off with, if I start with 6.7 moles of sodium, I'm going to now multiply this by the molar ratio to determine how many moles of chlorine would be needed. So I'm going to multiply this by the molar ratio. So again, my moles of Na are going to be down below here, and I'm comparing this to the moles of chlorine. So now notice how we're comparing the two reactants, not a reactant and a product. So we're comparing these two right here. What's the coefficient in front of the sodium? It's going to be a 2. What is it in front of the chlorine? It is a 1. So if I multiply 6.7, let's get another calculator that works. So if I have 6.7, I'm going to divide this by 2. This will give me 3.35. 3.35 what? Well, the moles of sodium cancel, the moles of sodium cancel. I now have moles of chlorine. So here's the thing. If I start with 6.7 moles of sodium, I'm going to need, this is what I need. So put need right there. I need 3.35 grams. Well, that makes sense because look at the ratio. The ratio is a 2 to 1. So if I have 6.7 of these, I would need half of those, or 3.35. Well, what do I have? In the problem, it's given me 3.2. So I need 3.35 moles, and I have 3.2 moles of Cl2. That's what I have. So here's the question. Do I have more than I need, or do I need more than I have? Okay, which number of these is larger? Well, the 3.35 is larger than the 3.2. Well, the 3.35 represents the chlorine that I need, and I have 3.2. So do I have more than I need, or do I need more than I have? So I need more than I have. Since I only have 3.2 grams of this stuff, and I would need 3.35 grams, or 3.35 moles, that means that this is going to be limited. So the chlorine is going to be limited in this because I need more than I have, meaning I don't have enough. So that also means that the sodium must be in excess. Okay, so let's kind of go back to this. Since my 3.2 moles is actually here, okay, if I doubled this because I have double the number of moles, I would have 6.4 moles of this. So I've actually been given 6.7 moles of this, and you can see that that's larger than this number here. That's going to show that the sodium is excess, which is going to mean that I can't get any more out, and the reaction can't go forward anymore because the chlorine is limited. Let's look at this from a different way. You don't have to actually start with this one. We can actually start with the chlorine, with the 3.2. So we'll do this one together as well. So if I start with 3.2 moles of chlorine, okay, question is, how much would I need of the sodium? We'd already did a calculation of that based upon what we got for our answer down here, but we're going to do this anyway, as if we didn't do this first part. So you don't have to do both of these. You can do either of them. You can use the information from this one, or you can use the information from this one. So if I start with 3.2 moles of chlorine, okay, I'm going to use my molar ratio again and go to moles of chlorine to moles of sodium. Once again, I'm going to be using my molar ratio. Moles of sodium is 2, found in the coefficient. What's the coefficient in front of the chlorine? It's a 1. So if I multiply these together, the chlorines will cancel out, and I will have 6.4 moles of sodium needed. How many moles do I have as part of the problem? I have 6.7 moles of sodium. So in this case, which is greater? Do I need more than I have, or do I have more than I need? In this case, I need 6.4. I have more than I need. So I have more than I need. If you have more than you need, that is going to make that substance excess. So I would say the sodium is then in excess. And I would say that the chlorine is going to be the opposite of that, and you would say the chlorine would be limited. So in the first case, we started with the sodium, and we determined we needed this much of the chlorine. But we have 3.2. We didn't have enough. We needed more than we had, which means that was going to be limited. In the second experiment, or second example, we started with the chlorine to determine how much sodium is needed. We determined that we have more than we need, meaning that the sodium is going to be in excess. So that's how you have to compare those numbers. If you guys can go on to the next page. So now determine living reactant comparing grams. So we're going from grams to moles to grams for this. So we're going to be looking at 90 grams of copper and 25 grams of sulfur. And again, you just can't look at the grams and say, oh, this is going to be limiting here because there's fewer grams. Well, remember, this is why you can't compare things on a gram-to-gram basis. You have to compare things on a mole-to-mole basis, which is why we have to do all these calculations. So here's the reaction this time. So here are our coefficients. Starting off again with 90 grams of copper and 25 grams of sulfur. It does not matter which one that you start with, but we're going to go ahead and start off with the copper. So again, I have 90.0 grams of this and 25.0 grams of this. We have to convert both of these to moles by using the grams, moles, moles to grams. So we're using the whole 3 steps right here. Now, in this case, again, we're comparing the 2 reactants, not a reactant and a product. Okay, so this should actually read grams of reactant 1, moles of reactant 2 to grams of reactant 2. So we can go ahead and change that. So let's start off with my 90 grams. So if I have 90.0 grams of copper, what would I need in grams of the sulfur? So this is going to be 3 steps. So I'm going to now, this is why it's good to have the practice with the grams, moles, moles to grams. I'm going to cancel my grams of copper and convert to moles of copper. Okay, 1 mole of copper, if you look at the periodic table, is 63.5 grams. So the grams of copper cancel and the grams of copper cancel. We've just converted the grams of copper into moles of copper. So now we have moles of copper. So now we need to convert from the moles of copper to the moles of sulfur. So we have the moles of copper to the moles of sulfur. This is the molar mass. This is the molar ratio. So the molar ratio, we have to look at the coefficients. How many moles of sulfur do I have in the reaction here? I have 1. How many moles of copper do I have? I have 2. So now I've converted from moles of copper to moles of sulfur. We're on the last step where we need to convert from the moles of sulfur to the grams of sulfur. So what I'm going to do is cancel my moles of sulfur on the bottom and convert to grams of sulfur on the top. 1 mole of sulfur, if you look at the periodic table, is going to be 32.1 grams. If you put this on your calculator, we have 90 times everything on the top, which is 32.1, divided by everything on the bottom in parentheses, 63.5 times 2. That will give me 22.7 grams. So I would need 22.7 grams of sulfur. How many do I have as part of the problem? I have 25.0 grams of sulfur. Okay, do I need more than I have, or do I have more than I need? I have more than I need. If you have more than you need, that's going to make that substance what? Sulfur is then going to be excess. So what's going to be limiting? Copper is therefore going to be the limiting reactant. So we converted from grams to moles to grams, comparing the two. And then at the very end, you then have to do a comparison. And if you remember, we're looking at this, you just can't say, oh, this is the lesser amount, therefore this is going to be limiting, because it turns out the sulfur is actually excess. Having more grams is actually limiting, and that's due to that copper weighs a lot more than the sulfur. So this is the work that you would need to calculate what is excess and what is limiting, going from grams, moles to grams. So based on the limiting reactant, determine the amount of product that can be produced. This is going back to the ham sandwich. If you remember, we had 8 slices of bread and 3 slices of ham. We can only produce 3 ham sandwiches. So very similarly, we're going to try to determine the amount of product based upon the amount of the limiting. So we have to ask, what's limiting? Well, the copper is limiting based upon the limiting reactant, which is copper. Okay, so now we have to start off with the amount of limiting reactant. Well, this is the amount right here, which is the 90 grams. So, based on this, determine the amount of product. I want to find out how many grams of product, which is going to be my Cu2S. This again is a grams to moles to grams problem using the copper and now the copper sulfide, which is this product over here. So we don't have to do if, need, or anything like this. We're just going to start off with my 90 grams. 90.0 grams of copper. Okay, we're going to convert the grams of copper into moles of copper. 1 mole of copper weighs how many grams? We had that previously. It's 63.5 grams. We cancel off the grams of copper. Now we need to cancel my moles of copper. So we'll cancel the moles of copper, and we're going to convert to the moles of the product. The product is my Cu2S. Where do I find the numbers for this? It's the molar ratio. So Cu2S, there's a 1. For the copper, there is a 2, using the coefficients. So the moles of copper cancel. Now I have moles of Cu2S. So So I want to cancel my moles of Cu2S, and I want to convert to grams of Cu2S. 1 mole of this weighs, well, how do we get that? This is the atomic mass. This is a compound, so it's going to be the sum of the atomic masses. We need now to get to the molar mass of this. So I have my elements of copper and sulfur. I have 2 coppers, 1 sulfur. Copper weighs 63.5 from over here. Sulfur weighs 32.1. If you take 63.5 and you multiply by 2, you'll get 127.0 grams. This will give you 32.1 grams. When you add those together, you'll get 159.1 grams. And that goes up here, 159.1. So now we need to multiply everything on the top and divide by everything by the bottom. Don't forget to use your parentheses. Try it yourself. 90 times 159.1, divide by parentheses 63.5. And when rounded to 3 digits, we started our problem with 3 digits, this comes out to be 113 grams of copper sulfide. So that's my answer. Very, very long problem. You have to do grams, moles, moles to grams, determine what's limiting, use what's limiting, then go grams, moles, moles to grams from the reactant to the product. There's one more step, and that's calculating the percent yield. Okay, here's the formula for the percent yield. The formula is it's what you got over what is expected. And then we'll multiply this by 100%. So let's say that I gave you those amounts. I gave you 90 grams of copper and 25 grams of sulfur in an experiment. And let's say that you got the amount that was made during a laboratory was 103 grams. Okay, again, we would expect to have 113 grams. What's my percent yield? My percent yield is what I got divided by expected. So it's going to be 103 grams divided by 113 grams. This is what I got in the laboratory. This is what I got on paper and should have gotten. We multiply this by 100%. And it gives us 91.2%. So your percent yield is comparing what you got during an experiment compared to what you should have gotten based upon the mathematics. That's it.